Now we are going to solve a parallel circuit. Remember that when you have to solve an electric circuit, the first thing you have to do is recognize the type of circuit. This is a parallel circuit because we have two different ways for the electrons, not only one way. So the current leaving the battery is going to be split. It's going to be divided one way through resistor number one, another current going through resistor number two. So the current leaving the battery, which is current without a number, is going to be split in current number one this direction and current number two this direction. So this is a parallel circuit. Start the exercise always writing the type of circuit and then the equations. So the equation for the parallel circuit, again, we have an equation for the voltage, another one for the current, and another one for the resistance. The equation for the voltage is that all the voltages in the circuit are the same. It doesn't matter if you have 2, 3, or whatever. The current of the battery is going to be split in different branches in parallel. But if I do the addition of all the currents, I get the current of the battery. And the equivalent resistance of the circuit is a bit complicated because I have to do the addition, but in fraction. 1 divided by the equivalent resistance is 1 divided by the first resistance plus 1 divided by the second resistance. Okay, my recommendation is using a table. In this table, remember, you can use a square for the total circuit. So you're going to write here the three magnitudes for the voltage, the current, and the equivalent resistance of the circuit, but as well one square for each component in the circuit. You have three squares. You have only two squares, and these squares you're going to write the magnitudes, because with this square you will have the opportunity to check if you can use the Ohm's law, which is the other equation you are going to use. Remember that the Ohm's law is this triangle, but the equation is voltage is equal to current multiplied by resistance. If you know 2 out of 3, you can work out the third one. If I have the data that I already know here, and I know 2 out of 3 in whatever of the squares, I can work out the third magnitude. So the next step is taking the information from the circuit to the table. I know the voltage of the battery, which is 5 volts. I know the value of the resistance, 5 ohms and 10 ohms. But I don't know more information because I don't know the value of the current. So I cannot use the Ohm's law, neither here, because I only know one magnitude in each square. So I need to use these equations. For example, first equation, if I know whatever of the voltages, I know the rest. In this case, I know the voltage of the battery. So this is the equation I'm going to start with. The voltage of the battery is the same voltage in all the components connected in parallel. And they are, in this case, 5 volts. I can take this information to my table. Okay, I have used this equation. Next, I have the opportunity to continue with these equations. Not this, because I don't know any current. This, I know this and this, so this is an option, but there is another option that is easier, that is using the Ohm's law here and here, because I know 2 out of 3. So I'm going to work out the current number 1 and current number 2 using the Ohm's law. Voltage is the voltage divided by resistance, voltage divided by resistance. Why voltage divided by resistance? Because if you use the triangle, if I want to work out the current, I hide the current and voltage divided by resistance. So in this case, for number 1, I have to use number 1, 5 volts divided by 5 ohms. So this is 1 amp, 1 ampere, and 5 volts divided by 10 ohms, 0.5 amperes. Okay, I have solved this part of the circuit, but I don't know the total current and the equivalent resistance. I now can use this equation because I know these two currents. So if I do the addition, I know the total current of the circuit. So this is going to be my next step. The total current of the circuit is the addition of these two currents, which is 1.5 amperes. If I know the current in this direction and this direction, I know the current getting this point. So it is 1.5 amperes. And the only thing I don't know is the equivalent resistance of the circuit. I can work out by two ways. One is using the Ohm's law here. The other one is using the last step equation. I'm going to use both, and I'm going to check if I have done it well. I'm going to start with the Ohm's law because it's easier. The equivalent resistance of the circuit is the division between the voltage and the current, which is 5 volts divided by 1.5 amps, which is 3.3 amps. It's the same as 10 divided by 3. Okay? If I use this equation, I'm going to check if I have done it well. But take care because this is a fraction. So 1 divided by the equivalent resistor, the resistance is 1 divided by the value of resistor number 1, which is 5, plus 1 divided by 10. I have to do calculations with fractions. In this case, 10 is the minimum multiple. So it's like 2 plus 1, which is 3 divided by 10. Take care, 1 divided by the equivalent resistance is 3 divided by 10. So next step, I'm going to do this. This is what I have calculated. But the equivalent resistance here is below. It's not on top. I need to have it on top. So the next step is moving the fraction. So equivalent resistance is 10 divided by 3. Because here divided by 1 is like writing nothing. And this is the same of this. So my calculations, of this, my calculations are correct because the value of the equivalent resistance is 3.3 ohms, which is, this is not amps, this is ohms because it's the value of the resistance. The ohm is the unit for the current. And this is the end of the exercise.